Okay, I just wanted to tie things together here for this AKS 42 dilations of line segments and lines worksheet. First thing is I wanted to point out all the ones that are highlighted here, which is example 1A, 1B, C up underneath example 2, and then on the back, example 3A, 3B, 3C, and then E and F below there. All of those are dilations with the center of dilation at the origin. If the center of the dilation is at the origin, then all you're going to do is you're going to take your coordinates of your original points. Here's A and B, and you're going to multiply by the scale factor. So times 3 times 3, everything times 3, and there's your new endpoints. That's all you have to do on 1A, 1B, etc. Now the ones that are different, that's example 2, A and B, D at the bottom here, and then on the back D and G. Now what's different here is that the center of rotation, excuse me, not rotation, but dilation is not the origin. Okay, so for instance on this one the center of dilation is 2, 5. Right here in the middle, these are your directions. This is an algorithm for how to do this. It's basically taking the whole thing and shifting it so that the center is at the origin, then multiplying by the scale factor, and then moving it back to where it really is. So you subtract the center, distribute the scale factor, which just means multiply the point by the scale factor, and then add the center back in. Okay, that's the opposite of subtracting it. It's basically just moving it back over to where it was. That's what you do for this one, and you get these answers. That's what you do for this one, and you get these answers. It's also what you do for D. I wanted to give you a little bit more visual way of doing this. I showed this to you, but here it is again. Okay, theoretically, if I could find it. And I can't, so quickly, let me just draw it. It's basically, this is what's happening. You're taking a point, your pre-image. Whatever your pre-image is. You're subtracting the center of dilation. Okay, so that means if the center of dilation has a negative coordinate, you'd be adding that. Okay, that gives me a new point. So the subtraction problem gives me a new point. That point is where my point would be, the pre-image would be, if everything was centered at the origin instead of where it really is. Then I'm going to take that and I'm going to multiply that times my scale factor and find out, okay, if it were at the origin and I dilated it, where would it be? Then you add back in center of dilation, and that is your image. So this is the process. Okay, you're doing that again on 2A, 2B, and not to B, just kidding, or 2D. And then on the back, we're going to have to do that on D here and G at the bottom. Now I've made a separate video for G because we started it in class. D I started to do on here, and it's just a mess. I didn't finish it. We need to figure out what the y-intercept is going to be. So I'm going to go ahead and do D right now. All right, so on D, it says line L is given on the graph below, graph the image, da, 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 da. And on that line, I have a y-intercept of 0, 2, and an x-intercept of -2, 0. So those are the 2 points I'm going to go with. I'm going to use those 2 points, and basically I'm going to do this process to each of them, okay, and then find the line through those new points. So my center of dilation is 4, 5, 4, -5, excuse me. So I'm going to start out by subtracting 4 and subtracting -5. So that's -4 and that's +5. So that gets me to -4, 7, -6, 5. This is where A and B would be if everything were shifted to have a center of dilation at the origin. That means now I can just multiply by the scale factor. So times 1/2 on everything here, and it would have to be 1/2, wouldn't it? So it's not going to be nice and clean and tidy. Okay, so that's, and I just did it as a fraction, everything is a fraction first. That's negative 2, 7 halves, negative 3, 5 halves. Again, this is where it would be after the dilation if everything was centered at the origin. Okay, everything in here is me working with what if it were centered at the origin, because I had done the shift. Now I need to take it back away from the origin because it's not centered at the origin. So I'm going to do the opposite of subtracting that point, which is adding it. Basically, I subtracted 4 up here, so I'm going to add 4. Added 5, I'm going to subtract 5. And again, the fractions make it a little bit messy. So if you need to work on that on a separate sheet of paper and get your common denominator and everything, great. This is 2, negative 3 halves. And this is 1, negative 5 halves. Okay, so these are 2 points that are on my line after the line has been dilated. If I want to know where the line is, well, for one thing, I already know the slope, and that's the beauty of this. Remember that any dilation moves it so that it's parallel to the old one. So I already know that it's y equals positive 1x plus some y-intercept. I just don't know the y-intercept. You could use the point slope form here, but I'm just going to go ahead and plug in one of these 2 points and find the y-intercept. So might as well use the first one. Negative 3 halves equals 2 plus b. So negative 3 halves equals 4 halves plus b. Subtract 4 halves from both sides, and I get negative 7 halves. So b is negative 7 halves. So my new line is y equals x minus 7 halves. And that's my answer for D.